Now, another way to give different images is to use the image width. In this example, instead of specifying the resolution like 1x, 2x, what we do is to specify the intrinsic width of the image. What do I mean by that? I mean the actual width of the image file. And you can find that by checking the information of the image. Remember when we began this responsive image section, I checked the image width of each of those image files. The first one had a width of 640, the second 1280, and the third 1920. Now, remember that the value for this is width, and we're not going to be using pixels here because we're talking about the actual width of the image. Now, what's the purpose of this? The browser will look at these sizes and choose the best based on the size of the viewport or whatever screen size it's being requested on. Now, I am going to be using Safari for this lesson, of course, because I wanted it to be more responsive. But of course, you can use Google Chrome and other browsers. I will talk on changing the pixel density later, but for now, let us remain on 1x. So if I increase the width to 546, it is still on 1x. If I increase it to 634, it is still on 1x. Now, if I increase it to 709, the browser decides to choose 2x. Why? Because at this junction, it has passed the width of the smallest image. Remember that the smallest image has a width of 640. So by the time we have a viewport that is greater than that, it looks for the next bigger image, which is the one of 1280. So even if I increase it to 1024, it is still 2x. Even if I increase it all the way to 1214, it is still 2x. However, if I cross over to 1312, it moves on to 3x because now the width is now greater than 1280. So this is slightly different from pixel density. This one deals with the width. However, there is a tricky part to this. We're imagining that all these screens are 1x. So 1 dot is 1 pixel on the device. However, you have some devices that might not be so wide, but the pixel density is high. So for example, let's say we have a width of 340. Normally, it should have 1x because, of course, it is less than 640. But what happens if the device was actually a 2x device? Now, for a 2x device, it will need an image twice the width to actually fully fit in to that viewport. So if the width is 340 and it is a 2x device, it actually needs an image of 680, which is 340 times 2. And because that is greater than the lowest image, it moves on to the next one, which is 2x. So it all depends on the width and the pixel density. Now, even if we make it 3x, it will still use the 2x image because even if I multiply 340 by 3, it is not greater than 1280. So because of that, the 2x image still functions here. Now, we can check another example. Let's go back to 2x and increase the width to, let's say, 718. Now, if we refresh this, normally a width of 718 should be 2x because that is greater than 640 but lower than 1280. But because it is a 2x device, it will need an image twice the size of that width. And in the resources, the only image that can supply that is the 3x image. So that is why we have 3x. So normally we have our width But by the time you start taking into account the pixel density, it becomes a little tricky.